Okay. Um, so the next topic that I will discuss with all of you is related to material requirements planning, MRP, and ERP, enterprise resource planning, enterprise resource planning. But I'm not going to go too much detail on ERP. I will focus mainly on MRP, material requirements planning. Okay. So if you remember, we did a lot of inventory control models way back in chapter 12, if I'm not mistaken. Okay. So that is actually you are developing models for independent demand. Independent demand means the demand does not depend on any other items or any other components. Okay. So this MRP, material resource planning, is a planning tool. First of all, it is a planning tool. It's a planning tool, and it's actually for dependent demand. Okay, so we're going to focus on dependent demand, things that you can plan ahead and how much you actually need. And this is actually dependent inventory model requirement, dependent demand inventory model requirement. So it's a planning tool. And we will see the MRP structure and the material resource planning management. It's actually a management tool on how to plan your production forward, okay, rather than wait for, where for example there is no parts on the production line, then suddenly you need to stop production or you need to have urgent orders. Okay. So we have this system in production, or not only in production but also in service organization. And I'm not going to cover that lot sizing and so on. Okay. A little bit on MRP services and ERP, not much on that. So so by the end of this chapter, you should be able to develop a product structure. First, we need to have a product structure. All products or any food for that matter, when you say product structure, it can be, for example, if you make a burger, a burger will consist of bun and then the burger patty. Have you noticed, how burgers are being produced? So there is a product structure for that. And we are going to develop a product structure. I will introduce to you the gross requirement plan. We'll build that up, okay, and then we'll build a net requirements plan. Okay, and I think mostly on the three things. Okay, three things. Right. I have a video on this which I've downloaded. Okay, which is the Wheel Coach. Uh, imagine that this is a big company, largest manufacturer of ambulances in the world. There's a lot of ambulance, right? If you have seen ambulances, okay, and especially in today's COVID time, so you'll see a lot more of them plying the road, and in Malaysia especially. So the largest manufacturer of ambulances in the world, it is an international competitor. And they produce 12 major designs of ambulance, meaning 12 different variants, okay, types. And from these 12 designs, they have 18,000 different items, parts. Okay. For example, I don't know, the oxygen tank, or the stretchers, or the equipments, that is the medical equipments and so on. So 6,000 manufactured parts, 12,000 are purchased parts. That means from this 18,000, 6,000 is manufactured, 12,000 are actually items that you buy, okay, from suppliers to be able to fix or to assemble into the ambulance. Right. So the material plan, so they have 4 key tasks. The material plan must meet both the requirements of the master schedule. That means they have a master schedule before you remember last week we talked about aggregate planning. For example, aggregate planning in 1 month, you need to produce 5,000 units. So from these 5,000 units, how are you going to meet the demand? When you break down into days or daily production, okay? How many, you need to order, for example, tires. When will you need to order the tires until, there is lead time in order for the tires to arrive. Okay, so this is included in the plan. So it depends, requirements must meet the requirements of the master schedule, okay, the schedule, and the capabilities of the production facility. Okay, so in this case, probably there is no, you cannot subcontract out the ambulance, all are going to be produced inside. But the components, yes, the components will be sourced out and sourced from suppliers. And the plan must be executed as designed, and you want to minimize inventory investment. So that's why you have JIT, just in time system. Just in time. The parts will come just in time. And you need to maintain excellent record for the inventory. The inventory must be almost like 99% accurate in order for the the production to be running as scheduled. Okay. So for any product in which a schedule can be established, we can use dependent demand techniques. Okay. So dependent demand techniques, dependent demand means, for example, I need to produce 100 units here. So this is, for example, day 20. Okay. So we have 20 days. So you need to break down this into the parts, the components, so that I can, for example, order how many tires do you need for 100 vehicles? If you have 100 vehicles to be produced, how many tires do you need? Tires, how many tires do one vehicle use? Jacob, Hong Li, how many tire in a car you produce or ambulance? How many tire? You know tires?
Yeah, I know.
Yeah, tires.
Naturally, 4.
Exactly 4. Okay, 4 tires.
Yes.
So you need 4 tires per car, per vehicle. So times 100 is going to be 400, correct? So this, for example, this is tire. So you need to order 400 for it to arrive here. So that is what we talk about. And we talk about how many to produce, how many to order, so that you have it and you can assemble it on time. Okay. So that's the meaning of dependent demand. So the benefits of MRP is that if you have MRP, you're going to have better response to customer orders. That means uh, you'll be able to meet customer orders on time. That means you can deliver on time. It's a planning. If you don't plan, according to what the order is, you're going to miss the order. When customer orders are not being fulfilled, your customers will feel frustrated, okay? Or even they'll change supplier, they change the manufacturer. Faster response to market changes, and then improve utilization of facilities and labor, because you know that your facilities are going to be utilized according to the time, okay? And you can reduce inventory levels because you're going to only order according to the required quantity, okay? Now, let me see. Okay. So other things that the demand, when we define dependent demand, it means the demand for one item is related to the demand for another item. I gave the example just now. The demand of tires, it depends on the demand for, the vehicles that you're going to produce. So given a quantity for the n item, the demand for all parts and components can be calculated. Okay. So if you know the quantity, for example, you need to have, I don't know, when you use screws, okay, you have 10 screws. One product, 10 screws. So if you're going to produce 10 products, you need 100 screws. Okay, that's kind of the backward thinking, the backward planning. And in general, dependent demand is used whenever a schedule can be established for an item. So when you can establish a schedule, then you can use dependent demand. And for dependent demand, MRP is the common technique. Okay, the most common technique is MRP. Probably just to show you what is okay. Use MRP, okay. This is MRP. This is when I say the MRP, this is MRP. This is MRP. So we're going to actually develop this. Okay, it looks complicated, but it's not that complicated actually. It's not that complicated. Now, so this is before probably I go further. Let me just share with you the video that I have downloaded just now. Can you see the screen?
Yes.
Okay, let me see whether I can see can you hear the sound?
No.
No sound. Okay. Let me just share. Okay, share sound.
Materials Requirements Planning, or MRP, helps managers control inventory needs where demand for raw materials is dependent on the finished goods to be produced.
Carefully.
Once a vehicle is configured, the MRP system tells all the components that are dependent on that design. As this illustration shows, the inputs to an MRP system consist of the master production schedule, product bill of materials, component lead times, existing inventory data, and outstanding purchase orders. The MRP software then produces outputs such as materials needed by time period and by date, planned order reports, and purchase orders. Wheeled Coach installed its MRP system in 1994 at a cost of hundreds of thousands of dollars. The software, called Mapix, runs on an IBM AS400 computer. Bob Collins, president, was instrumental in the system's installation.
An MRP system is crucial in Wheel Coach gaining control of its inventory. Having a system that helped us with our purchasing, it also helped establish a method to taking our in-hand balances and pegging that to a specific work order. By doing so, it enhanced our inventory controls, it reduced our inventory levels dramatically. Wheel Coach used the current systems that we have now in JIT and cycle counts. Those haven't changed since we implemented MRP. But prior to MRP, we were using historical information to be able to develop a model for what our future purchases should be. It took all the information and broke it down to what each item, what those past requirements had been. Obviously, with that type of system, there are faults. You're looking behind where you are currently and trying to determine where you're going in the future. With those type systems, you're going to make mistakes. We did the best we could, but our inventory levels were extremely high. We had instances where we didn't have the part when we needed it. Those type systems just do not deal with change as well as they should. In an environment that we're in right now, emergency vehicles, being a custom manufacturer, change is the name of the game. We needed a system that was far more flexible than that system offered us.
Let's take a closer look at the MRP process for one of Wheeled Coach's products, the Moduvan.
The first part of the process is when we quote the product to the customer. Being a custom manufacturer, obviously when we quote that customer, a bill of material needs to be created if we're going to cost it accurately. The bill of material, for instance, for our Moduvan product is the building block that really drives MRP. Each vehicle that's in our schedule contains a separate, specific bill of material for that product. When an order is submitted into the system through our order entry, it becomes live in the system and begins to drive requirements. We produce a report on a daily basis for our purchasing department that they review that determines what they need to do to support manufacturing. It gives them a lot of information which they use to not only purchase, but also be able to determine whether their on-hand balances are adequate or not.
Once a customer has specified the features of a Moduvan, the MRP system gives managers feedback that helps in ordering and using just the right inventory items. The system is driven by Wheeled Coach's master schedule, a detailed plan that shows production commitments for the next 2 weeks.
We've maintained a 2-week frozen period. We feel the 2-week frozen period is adequate to go out and buy material from outside vendors to support our manufacturing process for that time span. It doesn't mean that we don't have schedule that goes out beyond the 2 weeks. We just choose to freeze that time span to make sure that it's structured and cannot be changed without proper approvals. That way, it doesn't interfere with our planning process. Once we plan for that time span, we know that it's cast in stone. We use schedules that go way out beyond the 2 weeks that we use to drive material requirements on some of the longer lead time items. There are certain items in our inventory that fall outside the MRP system, primarily because of lead times. MRP only allows us about a 3 to 4 week planning time frame. We find things like chassis, aluminum, plywoods. Because of our long lead times, we need to deal with it in a different manner. For example, aluminum requires a 6 to 8 month planning period. Because of that, we need to deal with that in a different manner. Chassis is another example. We're dealing with a 90 to 120 day planning period there. So we find we need to deal with those separately, and we develop plans and programs to deal specifically with those items.
On occasion, an error in the bill of materials will surface during production. When identified, a team of Wheeled Coach managers is called in to review an engineering change request. Participation by managers from different functional areas is key, since changes may affect more than production. If the team approves the change, an engineering change notice, or ECN, is signed. The ECN must be processed by the MRP system before the change is made, and the required part is released to the assembly line. Employees also develop ways to improve a part or product. These too must go through the ECN review process. Materials requirements planning is the preferred way to schedule production and purchases when demand is dependent. Can you imagine the confusion Wheeled Coach's assembly process would experience without it? Now that would be an emergency.
MRP has made tremendous strides in our ability to keep our inventories at a manageable level. Our inventory turns on an annual basis have been enhanced greatly by giving us that control. By the systems that we used to have, we were creating obsolete inventory and then obviously then having to deal with that obsolete inventory. Our inventory now is all live and active and has given us controls we never had before.
Okay, it's a bit explanatory. It's a bit long, but that is what MRP is about. Actually, I'm going to what we're going to do is not using the software, because there is a software. There is a MRP software. What I'm going to develop with you is, the elements that actually build up to develop that, that calculation, that MRP system. Okay. I think you heard just now there is the bill of materials, the master product schedule. Okay, so those are the basic elements that is required. Now, so this dependent inventory model requirements require the MPS, master production schedule, the specifications or the bill of materials. So we're going to build this up. Okay, there is this the product structure when we can develop the bill of material. And what are the things that is required? So these are the information needed. So in order to develop this so-called the requirements, the net requirement or the gross requirement. So you need a production schedule. So we need to have a quantity that is being ordered or what is a demand. Then we use our bill of material in order to determine when how many we actually require in order to build up the product. Then you have to check inventory availability, as well as purchase orders outstanding. If some components have already been ordered but not received, so we have to put it into the so-called planning. And you must know lead times. Basically, if you do not know lead time, you cannot actually have, you cannot do the planning basically. Okay, if you do not know the lead time, for example, how long does it take to manufacture this? 1 week, 2 weeks, before you can actually use it, because before it is going to be assembled into the final product or the sub-assembly. So master production schedule will specify what is to be made and when is to be made. So the first information is the MPS. So in MPS, it will specify what to make and when to make. And it must be accordance with the aggregate production plan that we have actually seen last week, okay? It must be based on the aggregate plan. And other things, you need input from financial plan, because sometimes in MRP, you can put in cost elements, can actually have costing into the final product. Then you have input from customer demand. Of course, these are information that must be made available before you actually finalize the plan. Input from engineering, from supplier performance, because you want to know which supplier is actually reliable or which supplier is not reliable. And when you move, as the process move from planning to execution, remember just now they have, in the video it says 2 weeks froze time. That means for that wheel coach company, he actually used 2 weeks MRP, they lock the schedule, so they cannot change the amount to be produced and so on. And MPS is actually the result of production planning process. So you need master production schedule, meaning that you want to know which particular week, what is the quantity required, okay? So MPS is established in terms of specific products. Remember just now they say that if they have 12 variants, okay, you just look at one variant. It's simple like this. If you make cars, there is sedan model, there is coach, there is hatchback. Okay, these are variants. You know, the seat for, luxury 1,500cc is different than this 1,300cc. So these are different specific products. Okay, schedule must be followed for a reasonable length of time. So it depends on the organization, 2 weeks, 4 weeks. And MPS is quite often fixed or frozen. Okay, that's now the company said 2 weeks frozen. That means from the 2 weeks, they will generate the MRP. They will generate the daily planning quantities. And MPS is a rolling schedule. That means it will be For example, these 2 weeks, then coming up with the 2 weeks, and then come 1 month. It's a rolling schedule until the end of the, for example, if 1 year, then you have a 1 year MPS, 1 year master production schedule. It is a statement of what is to be produced. Okay, I hope you know, you can follow what I'm saying. What MPS is, how many to produce, because this quantity will meet the demand. Customer order is going to be, for example, you know, you're going to produce 1,000 cars, okay, for next month. So that is, you know, your master production schedule, and of course depends on the forecast as well. So this is where the whole thing, okay, I think remember last week we talked this. Last week was actually aggregate plan, and from the aggregate plan they produce the master production schedule. So master production schedule, they have the quantity required for a certain period. Then from here, you develop your MRP, Master Requirement Plan. It is iterative, okay? You can change your master production schedule, but of course, you know, if you change too often, then it will be costly to your organization. You cannot be changing your schedule every day. It's just, you know, going to be very, very tedious. For example, today, suddenly you change, we're going to produce 200 cars. And then suddenly tomorrow the manager say, okay, no, we're not going to produce 200, we're going to produce 150. What's going to happen? So it's going to be haywire. It's going to be chaos. So that's why you can change, but there is just now he said 2 weeks frozen. Frozen means cannot change. Yeah? So your 2 weeks, you can develop your MRP based on that 2 weeks. Then only you execute. This is the actual production. Okay, actual production or actual making. This is still planning. This is planning. But of course, the plan must go to the production line. Okay, and it relates to other things, right? Okay, it's the same thing. Now, so this is what we mean by master production schedule. From your aggregate plan, for example, from the aggregate plan, we say we're going to produce 1,500. Okay. In January. In February, 1,200. So we break down into our weekly planning. So the master production schedule, MPS, for this company, for this example, is on a weekly basis. Can you see here? Week 1, week 2, week 3, week 4. And it is now broken down. This is the gross. Remember last week we say it is the aggregate plan for the total. For example, if this is the total quantity of amplifier, okay? And the company produced 3 types of amplifier: 240 watt amplifier, 150 watt amplifier, 75 watt amplifier. So these are the variants. Okay, 3 types. And according to our, you know, we're going to break down, okay, according to our capacity and our availability, we're going to break down into 100 in week 1, 500 for this, 100. So this is depend on the organization. It depends on the capacity. It depends. So this is what is called as MPS planning. So we plan to produce 100 of 240 watt amplifier in week 1, 500 units of 150 watt amplifier in week 2, and week 3, 100 of this and 300 of this, and week 4, 500 of this. If you notice, you calculate this, the total is this. Correct? 100 plus 500, 600, 700, 1,000, 1,500. And so this is for January and for February. So this is what we call MPS. Okay, MPS. So our job now, from MPS, we are going to generate MRP. We're going to break this down and say, how are you going to produce this 100? Because this 100 depends on many other parts. You understand? This 100 of amplifier depends on different components that is built up into the product. So that's what, you know, at the end of the day, our objective is to come up with the materials requirements planning. Okay. Okay, this is a way of defining your MPS. It can be expressed in any of the following terms or any way. Can be make to order. That means you in a job shop, okay, in a machine shop, or in a tailor, for example, you make to order. Like the ambulance just now, it is okay. It's actually assembled to order. Okay, modules in a repetitive what do you call product. So, and different clients, different hospitals have different requirements. Correct. Different hospitals have different requirements for the different ambulance. Okay, so this is actually assembled to order, or even make to order. Also, it can be the same thing. And another way of expressing or defining MPS is the end item in a continuous company. Stock to forecast. For example, I want to stock up in, you know, maybe I produce microphones. Okay, microphones, and depend on the demand. Okay, so like these microphones. Okay, so this can be broken down into components, right? You can actually break down. So we can build the product structure for this. Okay. Any questions? I think it's we need to go to a specific example of a product, then you can see. Let me just, okay. You can also relate this to the, if for example, you're producing this is a master production schedule for Chef John's buffalo chicken mac and cheese. Okay. McDonald's. Okay, let's think about McDonald's. All of you are very familiar with McDonald's, correct? McDonald's. So let's focus on just the burgers. Can you tell me what kind of burgers they produce? What kind do you like? What kind of you know, burgers in McDonald's that actually you will you want to eat? But we cannot eat, Yaakob. But in Malaysia we can eat. Cheeseburger? Liang, cheeseburger?
I prefer fish burger.
Okay. So just take these two products. This is two products. Now, to make a cheeseburger, you need what? Tell me. You need the buns.
Yes.
Okay. Then you need the fish. We call it fish patty, no problem. Correct. And then what else? Is there cheese in
cheese? Yes.
There is
yes.
cheese. Okay, there is cheese. Okay. What else? There is
sauce.
Okay, sauce. And let's say lettuce. Okay, there's. Do you have lettuce there, or some?
No. Just 4 things, I think.
Okay, there's 4 things. Now for cheeseburger, there is bun. Same as this bun, right? I would presume, probably different. This has sesame seed. This doesn't have no sesame seed. Correct? Huh? And then burger patty. Cheese, sauce, and there is pickle, right? Do you know pickle? The sour taste, green, so this is, I mean, just give an example. Just for example's sake, this is 5 item, 5 component, 4 components. Okay. So for example, you know, the expected, so this, for example, this is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. You know that you're going to have daily production, not daily production, daily requirement. For example, cheeseburger in this particular store in Shinjuku, for example, it sells 200 of cheeseburger and 100 of cheeseburger. So you need to order this. If the lead time is 3 days, before this Monday, you need to order this. You understand? So these materials, these parts, now in cars, you call it parts, but in product like food, these are components that must be ordered. For example, burger patty require 7 days. So you need to order 7 days before. And if the quantity is high, for example, in Saturday, the quantity is 500 because it's holiday and people come and more people. So you need to order this like on Monday. So this whole idea of having this system of ordering and to replenish your stock, to replenish your stock or your inventory. For example, you say that from Friday we still have 100. Okay, so you have to count that plus, okay, and plus the purchase order, and it will become our ending inventory. So this kind of planning is required even for food. If we know the product structure, if we know the ingredients, so we need to know the ingredient basically. Okay, then only we can have the so-called, we call it gross requirement. Gross requirement. What is the total quantity required? So that brings me to this very nice, because this is an example of BOM. Actually, this is an example of bill of material, which is the next item that I'm going to tell you. I'm going to describe to you. So all products, all items that you're going to produce, okay, you can make a list of components, ingredients, and materials needed, okay? Materials to make the product. So this is what we call as the, you must provide a product structure. And so this is called bill of material, BOM. Some people, use the word BOM, B-O-M, okay? A little bit of terminology. Item above level are called parents. So for example, in order to make if we can break down, for example, this assembly, this is the parent, but it consists of item A, B, C. right? So this is the child. This is the children. This is the parent. So item below level is the component or the children. The above is the parents. Okay. So let's think about this amplifier. Okay, amplifier called Awesome. The product name is Awesome A. So at level 0, level O, which is the product level, the highest level. So this, for example, this is that ambulance or whatever that product. So in order to make Awesome, you need two big assemblies or component. One is component B and one is component C. And this number here, 2, represents the quantity required. For example, this is in order to make one of A, you need 2B, 2 of assembly B plus 3 of assembly C. Understand? So this is the child for A. And this is at level 1. So this is called the product structure. You know, you can break down the product structure. BOM, bill of material or product structure. Okay, then we go down to the next level. Next level means in order to make 1B, you need 2E. Okay, it says here to make 1, it doesn't, this number represents 2 of E become 1B. Okay, so if in order to make 2B require 4E. Understand? For example, this is like you know, for example, this part here. Okay, this amplifier. Probably you need this this small the woofer or whatever. Okay, you need 2 in order to build 1. So in order to make 1A, you need 2 times 2, 4E. Understand? Okay. And the same here, you need 2 of E. E is common. Common. They mean E is needed in C as well as E is needed in B. Okay. So this is a different, another component, another, you know, part. And this is at level 2. This is level 1. This is level 0. And as you go down, so this is the lowest level, which is D. Require 2 to make 1B. It doesn't, you know, so to make B, you need 2D and 2E. So this is like the glue or the screws or the low level. Okay, so this is D also, same D here too, right? So this is called the bill of material. All products, you know, will have a bill of material. I think because we are going to start, you know, from a small example so that you can see the logic, but the real life product has more complicated than this. Okay, you will have 100 branch or maybe, you know, many complicated, but this is a simple product structure. You can build a product structure for any of, you know, products that we probably have, or even food products. You can do this. Now, so for an order of 50, okay, can you calculate in order to make 50 awesome, how many, okay, you tell me how many B, how many C, how many D, how many E is needed? I know there is, the answer is on the next slide. The answer is on the next slide. How many E, F? Okay, there is, this is at level this is level 1 is okay. 1, 2, 3, 4, 5, 6. Okay, tell me if I want to produce 50. That's what is dependent demand. Okay, can you calculate and tell me how many B's? Okay, let's start with a simple one, B and C. Jacob, how many B do we require in order to produce 50 A's?
How many B will require for what in order to produce?
We are going to produce 50 of awesome. Awesome is the amplifier.
Amplifier, yeah.
50. We want to produce 50.
Mm-hmm.
How many B do you require? Remember,
100.
1A, huh?
100.
100, okay. So it's actually 2 times
A.
50.
2 times 50.
Because I say I want to have 50, yeah?
Yes.
So this can change, yeah? So it depends on X here. If it is 100, 2 times X, 100, 200. And how many C? Wengjia, how many C do we require?
150.
Okay, which is actually 3 multiplied by 50. Correct? 3 times 50. Okay, 150. Right, 250. Okay. How many G do we require? Only.
Okay. 300.
300. How do you get 300?
150 multiplied 2 and multiplied.
2 multiplied by 1.
Yeah.
Do you get the same answer, Liang? For G, do you get the same answer, 300?
Yeah.
Yeah, it should
Double.
be 300, but first
100,
C
yeah.
multiplied by F, that means 2.
Yes.
That means 150 into 2, 300. And again, G is 1 of F, that means it is 300.
Okay. How many E's do we need? How many E?
E,
Yeah, how many E?
300.
300.
It depends on D, all right?
It depends on C.
It depends on C and B because
Yeah.
there's 2 here.
Yeah.
So
yeah,
it is
2 here. Yeah, I got it.
300 plus, this is 300
200. 500.
plus,
Oh, total
Plus 200.
plus 200
plus 200.
because 2 times 2 times 50. Okay. So
Oh,
it's 500.
both sides we need E.
Exactly, because this is a product structure. So E is a material that is required for B as well as for C.
See,
Okay, so be careful of the, because, there are common parts. We call it common parts. Right, so for 50 orders, yeah, you're right. Okay. I think you're following, okay? So this is the whole idea. The whole idea is to have the quantity required, and you must have the product structure in order to complete your MRP afterwards. Okay. So modular builds are not final products, but components that can be assembled into multiple end items. Sometimes we have modular. Modular means the bigger assembly and bigger assembly, and you can simplify your planning. For example, today when they produce cars at the production line, they have brake assembly, they have engine assembly. So engine is assembled, and engine assembled are immediately installed on the production line. For the engine assembly plants, they have to have their own, individual components that actually being produced. Okay. Okay. I'm not going to go to this level. This is okay. Okay, you need accurate inventory records in order for you to maintain or make sure that your MRP is actually operating correctly, because the whole, the working of MRP depends on the accuracy of information. If you have because it's a software, and people will try to put in data information inside there and do the planning, and you print out the plan and give to the production line. So if your inventory records are not updated, you do not include the inventory in hand, so you're going to have false planning, or your planning is going to be not accurate, inaccurate, right? And also you need to have purchase orders outstanding. If you do not have the quantity of purchase orders outstanding, then you will be you will be not counting that into your inventory, or things that you must deduct that. Basically, you must deduct whatever purchase orders that actually in the pipeline. Okay. So outstanding purchase orders must accurately reflect quantities and schedule receipts. Schedule receipts mean when it's going to be available or going to be received by the organization, so that when it is arrived and is there, you can use the inventory. Okay. Another thing that we have to have information in MRP is lead time. Lead time for components, it depends whether the lead time is based on, it's either two things. Either you make it yourself, that means it is production, that means you produce yourself, okay, or you buy. So these both have lead time, okay. So the time required to purchase, produce, or assemble an item. For production, it is the total of all the time, moving, set up, assembly, running times, operation. So if you place an order, you must know that, for example, let's say F is production. So you need 3 weeks before you can actually have the parts. You cannot just say, okay, I want it now. There is no, it's impossible. It's impossible, okay? Even order for purchase items, the item between the recognition of the need, that means you suddenly realize that you don't have it now. And when is it going to be available for production? So vendors say, you must give me 3 weeks lead time. In this era of COVID, I think it is much more longer. Lead times are longer in this times of pandemic. Okay, how long does it take to order? Parts depends. Okay, so you need lead time information. You need purchase. What do you call? In purchase orders pending, and also you need all this the master production schedule. Okay, so in planning, we need to have this so-called time phase. Time phase means it is you can work backwards to find out when to start production, or when to the order to be sent out before it arrives. Okay, so this is a time phase product structure. So all the components, for example, just now we say we have this is again referring to the awesome product structure, okay, the awesome product structure. So in order to be able to make A, that means to produce A just now, you need how many weeks? So actually it takes, you need 8 weeks based on this lead time, based on this component lead time and this component A, B, C, D. Not A is not component, A is the product itself. So you need 1 week to produce the product. You cannot just instantaneous. Okay, so this is the same product structure, having awesome, and then there is B and C assemblies. There is D, E, F, G. It says here G is 2 weeks, F is 3 weeks. So if you break down into this time phase, okay, time phase. So I think we'll work backwards for you to understand. We work backwards. Forget about this. Let's see, we said to produce A, it takes 1 week. So I can start at the end of this week to complete this. Then only I can complete my A. Okay. Right. And C requires C 1 week of lead time. Okay. So only at week 6 I can actually start to actually, or you need 1 week to order. That means at week 6 I need to order. At week 6 I need to order, then only it will arrive. Or at week 6 I need to start making, then only it will be available at week 7 here. Okay. Same as B, 2 weeks to produce. So B is actually a production part. Okay. The rest are purchase. C is order, F is order, D is order, and so on. So this B is produce. So you need 2 weeks to produce this B. So you start at week 5, then only you can complete at week 7. Okay. And for to make B, you need D and E. Okay. So must have D and E completed so production can begin on B. So D will be need to be available at week 5 because we have 1 lead time. Okay, 1 week lead time, which is actually the start production of D. Okay, so D has this 1 week lead time. E has 2 weeks lead time. Okay, same here is 2 weeks lead time. So this is the time phase product structure for all the components or for making this product. Okay, same as here, D require 1 week, G require 2 weeks. Okay, so all products can be, it is showing if you work backwards and in order to be able to produce the final product, so there is 8 weeks lead time. So if someone you want to deliver to your customers, you make sure you have that 8 weeks of lead time, okay, in order to complete the order, right? Okay, let's take a 5-minute break. I think you takes a 5-minute break for you to have some rest. Okay, so have some coffee, and I'll continue a little bit after this. Okay. Let me just describe to you the MRP structure until gross requirement planning. Okay, I know this is a bit, difficult to visualize because if you have worked before, probably you can see some of these things. But it's a planning tool. Okay, it's a planning tool for production or for organization, for operations, basically. So we have already mentioned just now, time phase product structure until there is a concept which I didn't explain just now, the low level coding. So you need to actually go until the low level coding when you develop your product structure. So you have your product structure or your bill of material. So this is your product structure or your bill of material. you know your lead time, and you must have, if you have inventory, you need that information as well, and also your purchasing data. So this will be fed into the MRP program. Okay, so MRP program has all the information together with your master production schedule. And what it does is actually it will generate these reports. We will have output reports. That means MRP by period, report by period, or by date. This is by week, or days. This is by date. This is plan order report, purchase advice, and exception report, order not needed. You need to change order quantity too small or too large. So this is the so-called input, and you process to produce the plan. Okay, I'm going to explain the first one, which is actually gross requirement planning first. So first thing we need to, when you say gross, what do you mean by gross? Gross means is the total or the overall. Okay. So coming back to our example of producing 50 unit of item A, which is the awesome, amplifier just now. Okay. So start with the production schedule for the N item, which is 50 units of item A in week 6. So we need 50 of A at week 6. So using the lead time for the item, determine the week in which the order should be released. So the word is release, okay? Order release. Because 50 item A has 1 week lead time, that means the order for 50 units should be released in week 7. Okay, and this method is called lead time offset or time phasing. We phase out, we phase in actually. Week 7 released order, then week 8 A will basically be completed. Okay, so this is only gross. So we can move for all the item. That means from the bill of the material, every item A required 2 items of B. So we need 100 items. You already calculate just now, you know. Okay. So item B's are required in week 7 to satisfy the order release for item A. That means now we look at B and look at the lead time. Then you calculate the release order, which is backwards 2 weeks. So week 5. Right? So in order to be able to deliver that 50A at week 8, the order for A is week 7, but for B 2 weeks lead time at week 5. It is the planned release. We call it planned release. And the timing and quantity for component requirement are determined by the order release of the parents parts or parents assembly. So B and C, so you can do this for all the items. So you come up with the gross requirements. So the whole process continue to the BOM, one level at a time. It is called explosion. You explode until the lower level coding of the parts or components. Then you get the whole gross requirement. So by processing the BOM by level, items with multiple parents are only processed once. So you save time and resources and reducing confusion. So that's what the MRP software do. The MRP software actually will calculate. You can put it in Excel actually. This is, you put it in Excel and put in a formula, you can actually get the quantity, right? So this is very straightforward. So for this particular order of 50 awesome speaker kits, 50 A's, okay, so 50. So here, okay, you can look here, A 50. So at week 7, you need to have order release date. Imagine this is like, this is for weekly, but you can go down until, you know, on a daily basis, on a daily basis. So this is 50, it will reach, it will require 1 week. But you need 100 B to produce 50. So this actually goes here. And if you work backwards at week 5, you need to have order release date. So required date, order release date. 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 Okay. So you can see for E and for F, as well as D and G. Okay. A, B, C, D, E, F, G. Okay. Any question? This is gross requirement plan. Gross is overall, total. So if you go to the next level, which is what we call as net. The difference between gross and net is we are going to consider or take into account our inventory on hand, as well as purchased that item, whether it is coming into the system because of our ordering. Okay, well, because if we order the parts, it is waiting, it is coming. Okay, just to I'm not going to go to detail this week because I don't think I have time. Next week, definitely I'm going to explain in detail these net requirements. For example, this is the item on hand. A, we have 10, B, this is inventory. So given this information, given this data on inventory on hand, this is inventory on hand. Except for G, we don't have any inventory. So what it does is actually, because we say net, then for every, this is parent A, this is B assembly, C assembly, we are going to work backwards. We're going to work backwards in order to determine your so-called quantity required. Just, I'll show you A, for example. We did 50 at week 8, okay? But I have 10 inventory. So assuming this is just 10 all the way through, okay? So 10 inventory on hand. So the net requirement is only 40. So I don't need to produce 50. I only need to have 40 at week 8 because I have 10 already on hand. Because 40 plus 10 is 50. So if I plan release this backwards, remember 1 week lead time, right? 1 week lead time. On hand is 10. So my plan order release is going to be at week 7, but quantity is 40. Even though our gross is 50 just now, but this is your real MRP. This is your real, the actual quantity that you need to be able to produce. So from here, you bring down here 80 because you don't need 100. If you did 50, no stock, you need 100, but now we have stock. So 80, if you look at 15, so 80 minus 15 is 65. So you need plan order release of 65. So and so on, okay? And so on. So you can do this for the rest of the components and parts, and you can actually develop your so-called master net requirement plan, right? So you can work that for the other components depending on your whatever you have on hand. Okay, your stock. Okay. Right. Any questions? I'm not going to go to detail for this. We'll go much more detail next week. I want you to if you can go to, if you can open your book and see problem 14.3 and 14.4, which is actually an exercise for this product structure. Okay, product structure. So that will be, it's on page 630. If you can go to page 630. Let me share with you the book. Can you see the book now?
Yes, we can see it.
So it's on page 630. If you can, I would like you to try. This is a good example of developing product structure. 14.3. 14.3. Can you see it? Let me just follow. Okay, let's see. As the production planner for Jiangling Hue Products Incorporated, you have been given a bill of material for a bracket that is made up of a base, 2 spring, and 4 clamps. So you need to imagine this product, okay? So it doesn't show it just describe, okay, describe. So it describes the product. Can you read this? Can you see here? Bill of material for a bracket that is made up of a base, 2 spring, 4 clamps. That means this is a bracket. It made up of base, spring, and clamp. Clamp is 4, base is 1, spring is 2. Wakarimasu ka? Can you imagine? So the base is assembled from 1 clamp and 2 housings. Each clamp has 1 handle and 1 casting. Each housing has 2 bearings and 2 shafts. There is no inventory on hand. Okay. So design a product structure, show the lower level cladding, determine the cost quantity if you have to assemble 50 brackets. Compute the needed quantity if there are 25 of the base and 100 of the clamp in stock. And 40.4, continue, okay, continue. Your boss at Jiangling Hue Product has just provided you with the schedule and lead time for the bracket in problem 14.3. The unit to be prepared in week 10. The lead time for component bracket 1 week, base 1 week, spring 1 week. Okay, and so on. Prepare the time phase product structure for the bracket. In 1 week, you need to start the castings. Okay, casting is actually, is like a process for melting, and then it harden and become cast iron, for example, casting. Okay, why don't you do in pairs? You do in pairs because if you do alone, probably you will have, So I need 2 reports, two reports or 2 reports from Jacob. We can do with Hong Li, and then Liang we can do with Wengjia. I need 2 submitted reports from, not report, answers from two of you. Not two groups. One is Jacob and Hong Li. You can do together. Okay, and
No, we just count the answer.
the account and also develop the product structure. So you need to discuss. You need to discuss because this is quite a lot. Okay, quite a lot. So you can discuss. I'm giving you opportunity not for you to do by yourself alone because probably you don't have some ideas. So why don't Jacob you do with Hong Li and Liang you do with Weng Jia, and you try it. And if you have problems, you just WhatsApp me. Okay, and I need the answer by next week before next class. Okay, before next class, please submit this solution to the problem. It's a good challenge.
And both 43 and 44.
Both is both 14.3 and 14.4. Both.
44. Oh yes.
It is a continuation of 14.3. 14.4 is a continuation from 14.3. It's good because it shows the until you come up with the time phase product structure for the bracket. Okay. Okay, wakarimasu ka? Daijoubu desu ka? Boleh? Can? You can yatte mimasu. Yatte mite kudasai. Hai.
はい、わかりました。
Hai. Okay. I know this is. What's your opinion, Jacob? It's a quite difficult topic, right? Because you cannot see the how it function, right? Okay, I can understand because I've been teaching this for many years. Okay?
Yeah, that is it, Professor.
I've seen this the difficulty of trying to understand the flow, but I think the logic, you can see the logic, right? The logic of having this structure and calculation. Okay, any questions? Liang, Nanika?
Okay, got it.
If you have difficulty, please refer to this book. Refer to the book. Read the book, because this is explanation that you can find in the book. Okay, it's good reference, and you can immediately see the explanation. Probably the explanation, and when you read the book, it can become much clearer. Okay, because in the slides is very brief. Okay, so please read the book and do the assignment. Okay, right. So I'll continue next week on this same topic for the net requirements, and you can see other things relating to MRP. Okay, right. So now in Tokyo is very cold already, winter.
It is not very cold.
Not very cold, but it's winter.
It's not very cold yet. Okay, so December probably.
Now it is 12 degrees Celsius.
It's 12 was not cold. Okay.
But today maybe a little cool. It's 10 degrees.
10 degrees.
Yes.
But I think in China it's much colder, right?
In China.
China more cold.
Yes, China is cold. My hometown is 3 degrees.
3 degrees.
No. Yeah.
3 degrees. Okay. Okay, I will see you. Take care, everyone. Okay. See you next week. Thank you.
Okay,
Thank you.
thank you.
Okay,
Thank you.
bye-bye.
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 Bye-bye. Okay.
Thank you very much. Bye bye, Professor.
Okay, bye-bye. Thank you.